Good morning students, this is Junita Mukherjee in SS Public School. Once again I am with your physics class and today we will start the chapter electromagnetic waves. This particular chapter electromagnetic waves we will discuss first about the displacement current. What do you mean by the displacement current here? So the topic displacement current. So far we have done about AC, DC and now we will learn about the displacement current. In the Ampere's circuitry law, as we have discussed here, it is given by the property or the value that is line integral of the magnetic field along a closed path is equal to the mu 0 times the current treading towards the closed path, that is B dot integral line integral of B dot di is equals to mu 0 I. This is the particular equation for this Ampere's circuitry law, as you know that. So, where I is the net current treading in the surface bounded by a closed path itself, and this above particular equation is logically inconsistent. Why it is inconsistent? Because when we go through this particular law, this particular law holds the value mu 0 I. Okay, when we are going towards this particular formula, there is some illogical consistent in the equation itself. So, what happened? Maxwell has deduced this missing term. This particular missing term of the conduction current during charging of a capacitor was found inconsistent, and so Maxwell's introduced this missing term, which is called the displacement current in the Ampere's circuitry law, which will be logically consistent or logically consistent in this particular equation. So he has changed this particular law and he has added the electric field and electric flux in changing with the time itself in order to make the Ampere's circuitry law more logical. Displacement current is that current which comes into play in the region in which the electric field and the electric flux is changing with time. So we have here IT, this displacement current is given by this particular value. ID is equal to epsilon 0 d phi e upon dt. Okay, so that is what we can say Ampere circuitry law is being modified into line integral of B dot di is equals to mu 0 I c plus dt. So this particular change in this Ampere circuitry law, and thus the displacement current is being introduced here, and thus we got the value of B dot di is equals to mu 0 I c plus dt itself. Now, the Maxwell, this particular law is being given, and thus it has been changed, and this there are four laws of Maxwell's which we have given in this particular book, where we have Maxwell has introduced, or Maxwell has given four laws together. And what are they? The first one are Gauss laws of electrostatics. Second one is Gauss law of magnetostatics. Third one is Faraday's law of electromagnetic induction. And the fourth one is Ampere-Maxwell circuitry law. First one, Gaussian's law of electrostatics. It states that the total electric flux through any closed surface is equal to 1 upon mu 0 times the net charge enclosed by that surface. It is given by phi in line integral E dot ds is equal to Q upon epsilon 0. This is called Maxwell's first equation. Okay. Now Gauss law of magnetostatics. This law states that the net magnetic flux through any closed surface is always 0. It is given by line integral B dot ds is equals to 0. This is called Maxwell's second equation. In case of line integral, you can also say that is phi. You can say phi B dot ds. Okay. Now Faraday's law of electromagnetic induction, it states that induced EMF produced in a a circuit is numerically equal to the rate of the change of magnetic flux through it. It is given by line integral E dot di is equals to d phi b upon dt. And the fourth equation is Ampere's Maxwell circuital law. It states that the line integral of the magnetic field along a closed path is equal to mu 0 times the total current, that is the sum of the conduction current and displacement current threading the surface bounded by that closed path, and it is given by B dot di mu 0 IC plus epsilon 0 d phi E upon dt. This is called Maxwell's fourth equation. So this particular equation has been given by this particular value. I think I have made a mistake here in this particular equation. It will be ID. Sorry, I have made a mistake here. It will be ID. Because we have introduced ID here, displacement current, and this one is counting the conduction current itself. Here it will be a change in the displacement current. Mu 0 is equals to IC plus ID itself. Okay. So this particular value is being given, and thus it has been changed into different application, that is Maxwell's modified rule, Ampere's circuital modified principle is given by phi b and line integral b dot di is equals to mu 0 IC plus ID itself. And thus IC is the conduction current, and ID is the displacement current here. So I hope so this four equations on this displacement current is being told very much easier in this particular manner, and I hope so you have understood. So looking forward for yet another topic in this particular session itself, which will be concluded in this next video. Thank you, students.